Yes, now I think you'll be able to see my screen. Yes, I was explaining about the environment surrounding us. Many scholars are describing the situation that we are encountering nowadays as the next normal. And McKinsey came up with the three main changes that we see. First is the shift towards considering just-in-time only to a combination of just-in-time and just-in-case. And in the past, we had different situation from now, and we are seeing a possibility of a digital transformation, which will not be only about simple recovery from COVID-19. And one another trend that we are expecting is that environmental regulation and its compliance is not only being approached as an issue of compliance, but as an issue that will determine the core competitiveness of businesses. We shouldn't be making decisions based on slow data. We need to make decision-making faster based on data, and we also need to be flexible, operating based on rules. And we also need to be able to utilize new technologies. So this is the logistics governance that we will see in the future. First, we need to secure resilience of the supply chain, and the second direction that we should move forward is digital transformation, utilizing new technologies. And we also need to come up with a standardized governance structure and a structure that can support agile decision-making. The logistics industry is a very segmented industry. Compared to other industries, it is much segmented. And one another trait of logistic industry is that we are seeing a lot of companies newly emerging in this field. I think many presenters before me already mentioned these emerging players. We are seeing the introduction of digital forwarding services, and there are also data analytics services, and companies like Fleet are also joining the ecosystem. So the future of logistics industry will be quite different. We believe that courier service will go down in terms of ratio. So we need to have a clear asset or a clear platform in order to survive in the future as a logistics company. Professor Song Sang-hwa of International University also mentioned this concept of physical internet. This is a concept that is being talked about a lot nowadays. And when the data is moving from point A to point B, not only a single packet will move, but this packet will be dissected and then it will be combined again. And during that process, the data is moved from one point to another point. And just as we see this kind of phenomenon on the internet, we need to have this kind of a physical logistical structure. We need to share assets and also share data to create a physical internet environment in the logistics industry. As we need to operate our business in real life, I think there are some changes that we need to focus on associated with Logistics 4.0, which is similar to Industry 4.0. In the past, the mechanization of transports and mechanization of unloading and systemization of logistics management completely changed the landscape of the logistics industry. However, nowadays, we are witnessing changes that can be called Logistics 4.0 with the introduction of new technologies such as AI, big data, and IoT. So let me share with you some case studies. This is a case where AI was utilized in the supply chain network. forecasting is very important in supply chain management. Once forecasting goes wrong, you can experience inventory risk, and if forecasting is done incorrectly and we forecasted less demand than the actual demand, then we will be having shortage in inventory when we need to actually sell our products to our customers, and there can be a mismatch in inventory and demand. We analyzed German retail companies' sales data and also Samsung's sales data. And we used the 3-year sales data and 30 demand-related variables, and also 9 promotional information, what kind of promotional methods that we used. And combining these different data sources, we were able to increase forecasting accuracy. And let me show you a quick video on this. People are saying that they can't hear the sound. Well, you can refer to the subtitles here. So based on historical data and weather-related information, we are doing demand forecasting, and we are seeing and analyzing the weight between different variables, what kind of variables are having bigger impact on demand. And through these kinds of analytical techniques, we are improving forecasting accuracy. So, as I mentioned earlier, once demand forecasting accuracy goes up, it becomes easier to reduce the unnecessary inventory, and also we can increase the matching ratio between demand and inventory. Moving on. This is the second case using AI. We try to increase the ETA prediction accuracy using AI. We are collecting data which is worth 5 terabytes from global transportation market, and this is not only route data, but also weather-related data, and we are forecasting estimated time of arrival based on historical data and all these data we collect from our global transportation network. For example, from Long Beach to this final destination, what would be the estimated time of arrival? And we can also express the possible delay in ETA using different colors. For example, if the color is red, it means that there is a high possibility of a delay. And if the red light is on, then the shipper and the carrier can respond to this problem. So this is the approach that we are taking. And on the left-hand side, you can see an example. You can choose your vessel and choose the route of that vessel. Then you will be able to see the estimated time of arrival. And if there is a possibility of a delay more than 1 day, then you will see a red light alert. And then we will be forming a group to address that situation. I also have another video on this, but we will just skip it because it's kind of similar to the previous video that you just watched. The third case is market condition analysis. Mostly we have long-term contracts with our clients, and in this case, it is kind of hard to derive a consensus with the customer because even though we try to communicate with the customer continuously, there are different interests between different parties. So if there is an increase in supply, increase in oil price, all of these variables can impact our business operation. Because, for example, if the supply goes down, then the fare may go up, and there are these different scenarios. And sometimes the fare will go down when different companies partner up. So we will be performing a deep learning analysis on historical data on these different scenarios. And the accuracy level of the system was between 98% to 102% when we measure the accuracy of this AI-based market condition analysis system. But here, 1% difference can really lead to a huge reduction in logistics cost. So even if there are some shortcomings in the accuracy, I think this system is very helpful, and I think we already laid the foundation for such analysis. The next case is about optimizing the required resources by predicting the future volume of goods through SCM planning. We will have historical in and out data of warehouses. In fact, there are distribution centers which have holidays on weekends. In these distribution centers, probably the volume will go up on Fridays. And also during the peak season, the volume will go up. So if there is a fluctuation in the volume, we will have to adjust the workforce and equipment utilization ratio according to that difference. But because of such fluctuations, we were not able to adjust the workforce and equipment accurately. But using this forecasting based on AI and big data, we were able to better adjust the allocation of resources. We are not creating these IoT platforms ourselves, but we are trying to improve operational efficiency and expand logistics visibility by utilizing large amounts of data collected through IoT devices provided by our partner companies. And with regard to temperature management, for fresh groceries, we need to manage the temperature within the warehouses. And one of the recent examples that I can share is that we are installing sensors on equipment that can monitor the temperature in the warehouse and the shocks on cargoes. If there is a shock on the cargoes, it can lead to complaints of customers. In this case, customers will blame the carriers for the shock that was imposed on the cargo. But using IoT equipment and devices, we can figure out whose responsibility that problem is. So we are trying to develop this IoT platform and collect IoT data and analyze such IoT data so that we can have better business relations with our customers. I will also skip this video clip because it's similar to the previous one. Next, I want to share with you this virtual warehouse system. It's kind of hard to know whether this distribution warehouse is being operated properly or not. If the warehouse is managed properly and clean, we can check that, of course, visibly, but it is hard to track the level of optimization and the performance of the warehouses. Of course, we have the system called WMS, Warehouse Management System, but we can only use the data, the number-based data, numerical data in the WMS system. So we came up with this idea of creating a virtual warehouse system. In the past, the route was measured from one point to another point in a direct line. However, now on the CAD design drawing, we can really measure the route of cargo within the warehouse, and we can also color the different cargo inside the warehouse, the current status of the inventory based on the time that they were inside the warehouse. And here you can see which inventory is an aged inventory and which is a new inventory. And if you can see this slide, we succeeded in shortening the moving distance of aged inventory by putting aged inventory close to the gate. And we decided on the location of the inventory based on simulation, prior simulation. And the workers in the warehouse will be loading the cargo in a certain location based on the data that they have. So using the WMS command, they can reduce and shorten the distance that the inventory is moved by preemptively deciding on the location where the inventory will be placed. Next, indoor positioning service. We are measuring forklift movement inside the warehouse, and we need to monitor the movement of these forklifts within distribution centers. We used many different methods such as indoor communication, RFID, and so on. And we thought that the simplest way of monitoring forklift was to use our mobile phones. We can analyze the data collected through the mobile phone's camera. We can allocate a particular ID on a particular forklift, and we can accumulate data on the movement of that particular forklift. And if we use this forklift movement data, we can make relevant adjustments such as increasing the number of forklifts in certain location, and so on. So I would like to show you the results of our test. So on the left-hand side, you can see a video where a camera is installed and On the right-hand side, you can see the movement of the forklift. So on the map, on CAD, you can see the forklift movement is being marked. And on the bottom left, this red color represents the movement of forklift. So if the forklift moves frequently, then the red becomes darker. So on the left-hand side, on the bottom, you are seeing the forklift movement overnight. And this slide shows that the inventory was concentrated in one place because here there are lots of red colors. And because the forklifts are moving actively in the red area, it means there's a high risk of an accident. So we need to reallocate the inventory location and distribute forklift movement evenly across the distribution center so as to prevent accidents inside the distribution centers. Using Google Glass and smartwatches, you can pick cargo in the distribution centers, and we applied this technology in Samsung's warehouse. Let me show you this video. So this is a service warehouse for electronic appliance of Samsung Electronics. To enhance the performance of these distribution centers, we utilize smartwatches like you see on the screen. And the glass she's wearing is a Google Glass. And the worker can see a screen like this if she wears a Google Glass like this. And because she has two empty hands, she can work more conveniently. And using her Google Glass, she can access information about how many quantities of goods she has to pick from the shelves. And once the picking is done, then the results will be uploaded to the WMS system. This is an inventory survey using drones. This is not Samsung's case. It is a case of a company called Hardest Group. So drones are flying inside the warehouse and monitoring inventory. So let me quickly show you this video. So there are inventory on top of the shelves, very high in location. And normally workers will have to use this kind of ladder, and then he will be scanning the barcode on the top of the shelf like this. But now they are using drones, and drones will fly up high and find the location of the barcode and scan the barcode. So overnight, drones can scan barcodes like this, and the camera installed on the drone will be scanning the barcode like this. Samsung SDS is preparing something similar to this, but it is not to this level, but we are operating warehouses of many retail companies. The problem is that the barcodes are not standardized. Some barcodes are too small in size. Then the DPI level has to be very high to be able to recognize that barcode. So scanning the barcode accurately is a very difficult task. So the method that we are considering is using drones to scan the barcodes and to do image processing using drones. And we are planning to conduct a pilot program next year on this technology. Next is loading optimizer. Loading optimizer can be used in many cases. It has many use cases. It can be used when loading on pallets and loading on containers and loading on trucks. When you're loading on a pallet, there can be limitations such as gravity, the center of gravity, and the order of loading, and so on. Simply put, you need to consider the center of gravity of that cargo, and then you need to also think about the direction of the cargo, where the cargo should be faced, because the barcode should be scanned. So considering the center of gravity, the technology would have to be able to load the cargo in the right direction, in the right way. So let me explain by showing you a video on this as well. This is a warehouse for finished products located in East Europe. Products such as refrigerators and washing machines are stored here, and these products are distributed all across Europe. And we are optimizing loading here in this distribution center. In the past, of course, the loading was done by human beings, and it seems easy, but I would like to mention one point. I don't remember the exact number of trucks, but for more than 8 years, this person has been loading TVs on trucks. And if you search Samsung SDS cello on YouTube, you'll be able to see this video. And this worker was loading TVs on trucks, and he would normally load 18 TVs on a single truck. However, using this new loading optimizer, we could load 2 more TVs on the truck. And sometimes we can prevent a situation where 2 trucks have to go because of just 1 or 2 more TVs that need to be delivered. Using a camera, we will be calculating CDM, the height and breadth of the cargo, and using this information, we will use an algorithm to calculate the weight and the barcode direction. The system will be reviewing different scenarios, and the system will also simulate the center of gravity. And the order of this loading optimizer is shown to the worker like this, and the worker can optimize loading based on this data. So this is the optimization system of Samsung SDS, and here you can see the loading orders, and you can also check how many trucks should be used for this cargo. Now let me move on to the blockchain part. I think many of you are familiar with this blockchain technology. Blockchain technology is a distributed ledger system where the data is shared across different parties. And I think this is a technology that is really in line with the changes that we see in this era. Up until now, there were lots of attempts using similar technologies. The FDA in the United States also attempted similar things, and also there were similar trials in the Korean market as well. However, the reason why this technology is not taking root in the Korean market is because there are certain limitations. But if we can utilize this distributed ledger system in a wiser way, then it would be greatly beneficial. So let me take you an example of the Shipping Logistics Blockchain Consortium. BPA, Busan Port Authority, and the shipping companies all participated in this consortium. And we analyzed the impact of this blockchain technology on not only the shipping industry, but also the marine insurance industry and other relevant industries. I did prepare a video on this, but I will skip this. And it will have a lot of benefits, such as reduced risk in fraud and reduced cost in BL insurance and so on. Of course, we think that this change is inevitable and we will ultimately move to use blockchain technologies. But I think everyone needs to be involved in this change for this technology to become effective. Another option that we can consider using blockchain technology is to manage retail history. And we will be able to manage information by sharing data between different stakeholders, and this can have two benefits. First, we can prove the source of origin of food products, and this is an actual case that we are seeing. And the second case is identifying authentic and counterfeit luxury goods, for example. By scanning the QR code on this luxury product, for example, we can identify the source of origin and authenticity of this product. And recently, we used this technology on a premium water from Norway. There were concerns from the consumer side that the water quality might have changed during the process of delivery or transportation. So using this blockchain technology, we were able to prove that the quality of water remained intact. I also have a video on this, but I'll skip this as well. So the digital transformation framework that we are considering is something like this. At the moment, we have systemization of functional work units. However, we lack an integrated approach. In the post-COVID-19 era, we will see many changes in this industry, and the two major changes would be the greater need for a flexible supply chain, and the second would be the need for digital transformation. And if we delve a little bit deeper into two of these changes, first, I think when it comes to distribution centers or international freight shipping services, we need to be able to manage data on systems. And I think we need to think about how to increase the efficiency of logistics execution and also logistics management. From the perspective of increasing efficiency in logistics execution, we need to collect data from all processes end to end. And this data should not be collected by human beings because this is costly and this can also lead to time delay. So we need to have a system which can collect data real time. And secondly, we need to continuously improve productivity in the logistics industry. We are using robotics-based work optimization, which is called IPA. And through this automation, we can allow human workers to focus on creative business areas. We can also utilize new technologies such as vision picking and robotics and drone to improve productivity. We are seeing more additional logistical works occurring in the logistics chain. For example, picking and packaging are some of the areas where we are seeing more processes that are newly emerging. And also in the e-commerce market, we see some additional logistical activities that are happening. So we need to also improve the efficiency of these works. Not only increasing efficiency in logistics execution, we need to increase efficiency in logistics management by utilizing various kinds of professional solutions, such as virtual reality systems and so on. So whether it's offshore or onshore delivery, we need to optimize processes and we need to have a proactive risk detection and risk response system. Of course, in order to do so, we need to utilize mobile devices better so that we can share information with different stakeholders real time in a faster way. In our chat bot, if somebody types in BL, then relevant information will appear. But we are trying to replace these repeated works using technology such as chatbots. So we should focus on increasing real-time information processing using these different technologies such as chatbots. And one another important area is risk management, real-time risk detection and fast response. And each time an issue occurs, we need to be prepared with a response scenario. For example, if there is a port congestion issue in Southeast Asia, or let's say at Long Beach, we need to have a response scenario. For example, if there is a port congestion, we need to change the route in this specific way. And after coming up with this response scenario, we need to be able to practice the implementation of this scenario. So in this regard, instead of just focusing on converting analog data into digital data, we need to create a system where partner companies which are responsible for operation operate in an efficient way, and we should be able to optimize our performance by strategically locating our logistics resources. And if there is a crisis situation in a certain region, then we should be able to make decisions in an agile manner. And this is the direction that we are headed when it comes to digital transformation, and logistics innovation will have to continue in this direction. I'm 5 minutes behind schedule, but I would like to finish my presentation here. Thank you very much.